All right, everyone, we'll have a look at the board here right now. That's the answers to your homework last night, your work and power worksheet. 5 questions, 5 answers here. Any issues with any of those questions, please? Yep. Number 3, 4, 3 and 4. Okay, let's take a look at 3 and 4 then. Number 3, I think is probably the trickiest one. Number 3 says a weightlifter lifts 250 newtons of weight when doing curls. If he lifts a weight a distance of 40 centimeters in each curl, how many reps must he make in 1 minute in order to reach a power of 25 watts? I think that's a tricky question. Okay, what I'm going to do for this one is calculate, in number 3, the work done for 1 rep. Okay, for 1 repetition of lifting this 250 Newton weight. Okay, we know the work is equal to delta E. The initial energy of this weight is 0. It's on the ground, right? Basically, it's on the ground. The initial energy is 0, but the final energy is potential. So we're going to say final energy minus initial, the potential energy as this weight is at a height, minus the initial energy of 0. Now, we already know what mg is. The value of mg is given to me as 250 newtons, right? M times g is 250. Times it by the final height, 0.40 meters. 250 times 0.40 is going to give me, I think it's 100, isn't it? Gives me 100 joules. So the work done in 1 rep, lifting 1 250 Newton weight once, is 100 joules. Now, we want to know how many reps he must make in 1 minute in order to reach a power of 25 watts. So let's solve for the work that he has to do in order to do 25 watts of power. Let's use the power equation for this, W over T. Let's rearrange it and solve for work. It's power times time. The power is 25 watts. The time here is 1 minute or 60 seconds. So 25 times 60 would be 1.50 times 10 to the 3, 1,500. So in 1 rep, he does 100 joules of work. In an unknown number of reps, right, in that 1 minute, he does 1,500 joules of work. How many reps would he need to do of 100 joules in order to get 1,500 joules of work out of this? 15, right? We're just simply going to divide that, right? To get the power that they tell us we want here, which is 25 watts, and we end up doing 1,500 joules of work. Well, if we can only do 100 joules of work for each rep, then we got to do 15 reps in order to get 1,500 joules, which is 25 watts if it's done in 1 second, or 1 minute, I should say. All right, how many people got that? Good, good. I thought that's a hard question. Okay? So if you got that, that's good. 4. 4 is a little bit iffy, actually, a little bit sketchy. It says, a horse pulls a carriage filled with people around a circular track. I wish it didn't say circular track. I wish it didn't say circular track. Because in the end, if it's a circular track, what's the displacement? 0. What's the work? 0. That's not what they were intending here. So let's just drop that word circular. Let's just say the horse pulls people. Well, I guess we need circle because it's got a radius of 0.5 kilometers. Let's get the distance that it travels first of all. Okay, the distance that it travels is going to be 2 pi r, the circumference of the circle. 2 times pi times 0.5, which is going to give me 3.14 kilometers, or 3,140 meters. I want to find out the work done here. Well, strictly speaking, it's 0 because the displacement is 0. But if we pretend it's in a straight line here, which is what they were doing here as they were doing their answer key rhyme, then we're going to say 800 newtons times the displacement of 3,140 meters. And what do we get for that? 2.51 times 10 to the 6 joules. And if it takes 12 minutes, what's the horse's power? Power is equal to work over time. The work is 2.51 times 10 to the 6, although we really should use the unrounded number there. Divide that by the time of 12 minutes. 12 minutes, by the way, is 7,200 seconds, right? Or is it 720? 720, I think, isn't it? 720? 2.51 times 10 to the 6 divided by 720 is what? 3.5. Should be 2 digits, actually, yeah. So 2.5 times 10 to the 6 and 3.5 times 10 to the 3 watts, or joules per second. We said 1 horsepower is 750 watts, so this is somewhere in the range of 5 horsepower. So ironically, a horse has 5 horsepower. A horse is as strong as 5 horses. That's like Arnold Schwarzenegger. He's as strong as like more than one person. This horse is as strong as lots of horses. Strong horse. Is that good? All right.